Hello, welcome to today's notes on rational exponents. Today we're going to be covering two objectives on rational exponents. First, you're going to be able to convert rational exponents to radical form. Second, you're going to be able to convert from radical form to exponential form. So essentially, these two objectives are reverses of each other. Now you may be asking yourself, what is a rational exponent? A rational exponent is an exponent that can be written as a fraction. Rational exponent is an exponent that can be written as a fraction. So today you're going to see a lot of exponents that appear to be fractions. Contrast that with the first 2 days where we did only whole numbers as powers or exponents. So we're going to be able to go from rational exponents to radical form. Radical form essentially is just written in what's called root form or radical form. And we say radical or root to mean one of these. And you may have heard these called square root. It's the most common one we use in math, probably one you've seen before. Square root is just one type of many different types of roots. Okay, there are square roots, there are cube roots, and there's fourth roots, fifth roots, and so on, all the way up to infinitely many roots. Key aspects of a root. Okay, obviously it's going to be the same symbol every time, but there's one little number that goes here that's called the index. Okay, and this tells you how many roots you're taking. So for a square root, the number is 2. We just don't write it. We assume it's there. Okay. If the root is the third root, you put a 3 there. You say, oh, it's the third root. Fourth root, you put a 4 there. Fifth root, put a 5 there, and so on. Now, how do we actually convert back and forth between the two? Well, the first set of 4 examples ask you to rewrite the following rational exponents in radical form. This is your first objective on the top. So we have a base with an exponent that is a fraction. Two parts of the fraction are the numerator and denominator. So numerator and denominator. First thing I want you to do is rewrite the base and then rewrite a radical around it. Now these two numbers, the numerator and denominator, they go in a certain spot. The first one, denominator, that is the index of the radical. So, little statement here. The denominator in the exponent is always the index of the radical. The denominator in the exponent is always the index of the radical. The numerator is what the entire radical is raised to. In this case, the power is 1, so you could write it like that, or since it's the power of 1, you could just write fourth root of 3. And be done. Let's look at example B. Rewrite the base, put a radical around it. Look at your denominator. I would usually look at our denominator first. It is a 7, so this is a 7th root, and it's all raised to the power of 3, because that is the numerator. Repeat the same directive for letter C. Rewrite the base 7, rewrite a radical. The index is 4, so it is a 4th root, and it's all raised to the power of the numerator, which is 5. Lastly, letter D, rewrite the base, it's x to the power of 1/2, so it's the radical around the x. Now, if we're repeating the exact same steps before, we're going to put a 2 there, and then we're going to put a 1 on the outside. The simplified version here is just this. We assume there's a 2 there when there's nothing there. So when there is no index written, then assume it is 2. So when there is no index written, then assume it is 2. So if there's a 2 supposed to be written there, we don't actually write it there. And the power of 1 remains the power of 1. We don't have to write the parentheses. So that's going from exponential form to radical form. Now, the second part here, you're going from radical form to exponential form. So they're going to give you a radical and ask you to write it in exponential form. So, first thing I want to do is rewrite the base. And then you're going to write a fraction for the power. Denominator is still the index, so the 8 is going to go on the bottom. Now, if you're looking at this first example, there's no set of parentheses around this radical, and so that means one set of parentheses wasn't needed, and that's only not needed when there's a power of 1. So they could have written it like this with the power of 1, but it's mathematically unnecessary. It means the same thing. Going to part B, rewrite the base. The index is 10, therefore your denominator is 10. And just like in case A, there is no set of parentheses with a power on the outside, so you assume it is 1. Moving on to example C, rewrite your base, your denominator. Your denominator is going to be 2. Now there's no 2 written there, but remember we talked about earlier, if there's nothing written there, you're going to assume it is a 2. The numerator is going to be the power on the outside of the parentheses, 5, so it's 9 to the power of 5 over 2. And last example, rewrite your base, rewrite your fraction. Your denominator is going to be the index, 7. And your numerator is going to be the power of 2 that's on the outside of the set of the parentheses. So this is your second objective for today. We have just completed 4 examples for both the first and second objectives. First one being going from rational exponents to radical form, and the second objective being the reverse or converse of that, going from radical form to exponential form. There are more examples on the back side of these notes that you can try on your own. You can check your answers with your table mates, and good luck.